Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be talking about empirical formulas and molecular formulas. Okay, so sometimes you might be asked to find the chemical formula of a compound given its percent composition. Now we talked about what percent composition is in the previous video. So in percent composition we took the chemical formula and then calculated the percent composition. So basically in this video we're going to do the same thing backwards, okay? So the steps to doing this is we convert the percents of the elements to grams. Then we convert all that to moles. We divide it by the lowest number of moles, and then from there we can determine the empirical formula. And these rules probably don't make any sense, so I will refer back to them as we do these problems, and it will make more sense then, okay? So here's a type of question where you'd have to be a type of question which involves empirical formula and molecular formula. Okay, so you'll get a question like this: a compound contains 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen. Its molar mass is 98.96 grams per mole. Determine the empirical formula and chemical formula. So let's first determine the empirical formula before we even look at the chemical formula. So first step here is convert the percents of elements to grams. So what we're going to do is we're just going to say, instead of having 71.65% chlorine, we're just going to say grams of chlorine, and then grams of carbon, and grams of hydrogen. Okay, that's the first step. Second, we're going to convert all these to moles. So we're going to convert 71.65 grams of chlorine to moles of chlorine, 24.27 grams of carbon to moles of carbon, and 4.07 grams of hydrogen to moles of hydrogen. So first, let's do this. So we want moles of chlorine, and what we are given is 71.65 grams of chlorine. So if you remember back into our first video on calculations using the mole, this is going to come in. Make sure you watch that video because we talked about how to convert from grams to moles. So it's very simple. If you look at the periodic table, you will notice that the kind of hard to see probably for you, but you might notice that the average atomic mass of chlorine is 35.453. Therefore, 1 mole of chlorine has a mass of 35.453 grams. And then grams of chlorine cancel out with grams of chlorine. We want what we started off with. We wanted moles of chlorine, and that's what we have. Now we can go ahead and multiply everything out and then divide. So 71.65 divided by 35.453. 71.65 divided by 35.453. And we will get this. Our answer needs to be rounded down to 4 significant digits because this number has 4 significant digits, this number has 5. So our answer is going to be 2.021. Okay, so 2.021 moles of chlorine. Alright, great. Now let's go ahead and do this for the next element. So for carbon, we want moles of carbon, and we're given 24.27 grams of carbon. So from here we know that 1 mole of carbon, if you look at the periodic table, the average atomic mass of carbon is 12.011, therefore 1 mole of carbon is going to have a mass of 12.011 grams. And then units cancel out, grams of carbon cancels out with grams of carbon. We're left with what we wanted, which is moles of carbon. Then we can go ahead and do the math here. So 24.27 divided by 12.011, we'll get this. Our answer needs to be rounded down to 4 significant digits. So our answer is going to be, we're going to write our answer down as 2.021. So 2.021 moles of carbon. And for the last element, here, let's convert this grams of hydrogen to moles of hydrogen. So how many moles of hydrogen is 4.07 grams of hydrogen. If you look at the periodic table, the average atomic mass of hydrogen is 1.008 grams, so therefore 1 mole of hydrogen is going to have the mass of 1.008 grams. From here, we can see grams of hydrogen cancels out with grams of hydrogen, and we're left with moles of hydrogen. So therefore, we can, from here, do the math. So 4.07 times 1 is 4.07 divided by 1.008. So our answer needs to be rounded down to 3 significant digits, so we're going to take our answer as 4.04. Okay, so we have that. Now, the next step says that divide by the lowest number of moles. So what that means is we have 2.021 moles here, 2.021 moles here, and 4.04. So what we're going to do is we're going to take the lowest number, which is 2.021, and divide everything by that. So we're going to say 2.021 divided by 2.021. Here also divided by 2.021. And here also divide this number by 2.021. And here we will get 1, this equals 1, this equals 1, and this equals 2. Alright, great. So from here we can determine the empirical formula. Okay, so next step, final step is determine the empirical formula. So from here we have 1 chlorine, 1 carbon, and 2 hydrogens. So the formula is going to be C1, so we're not going to write 1, obviously, C, just C, and then H2, because we have 2 here, and then Cl1, and just, we're not going to, again, write, we're not going to write 1 here, because that would be weird. So yeah, this is an empirical formula. This is the empirical formula. Okay? Now to determine the molecular formula, we're going to have to find, we're going to divide the molar mass of the molecular formula by the molar mass of the empirical formula and multiply the subscripts of the empirical formula by this number. So the molar mass, first we have the molar mass of the molecular formula here, 98.96. Let's then find the molar mass of our empirical formula. So in order to do that, we're going to have to say 1 mole of this consists of 1 mole of carbon, 2 moles of hydrogen, and 1 mole of chlorine. So 1 mole of carbon, if you look at the periodic table, the average atomic mass of carbon is 12.011, so therefore 1 mole of carbon has a mass of 12.011 grams. The mole, if you look at the periodic table again for hydrogen, the average atomic mass of hydrogen is 1.008, so therefore 1 mole of hydrogen has an average atomic mass, has a mass of 1.008 grams, so therefore 2 moles of hydrogen will have a mass of 2.016 grams. And finally, for chlorine, if you look at the periodic table, the average atomic mass of chlorine is 35.453. Therefore, 1 mole of chlorine is going to have a mass of 35.453 grams. And then we can add this up to get the molar mass of our empirical formula here. So 12 point, clear the calculator here. So 12.011 plus 2.016 plus 35.453, 35.453. And we'll get a total of 49.48. Okay, so the molar mass of our empirical formula here is 49.48 grams per mole. From here, we're going to have to divide the molar mass of the molecular formula by the molar mass of the empirical formula. So the question says that the molar mass of the empirical formula is 98.96 grams per mole. We're going to divide that by the molar mass of the empirical formula. So 98.96 grams per mole divided by 49.48 grams per mole. And this is going to equal 2. And then from here, we take this number 2 and multiply that the subscripts of the empirical formula by this number. So what that means is we're going to take 2 and say, we're going to take the empirical formula, so 1 times 2 is 2, so we're going to have C2. 2 times 2 is 4, so we're going to have H4. and then 1 times 2 is 2, and that's C, that's 2. So our molecular formula is C2H4Cl2, okay? This is the molecular formula. Okay. So very long process, but, you know, just be careful here. So we have our answers. Okay, let's go ahead and do another example here. How many examples do I have? I have 4. Okay. So let's work through this out. So again, same thing. So first step, just say these are grams. Next step is convert all of them to moles. So let's go ahead and do that. How many moles of sulfur is 31.42 grams of sulfur? 1 mole of sulfur has a mass of, let me see here, I think it's 32.065. 32.065 grams. Grams of sulfur cancels out with grams of sulfur, so we're left with moles of sulfur. And we can go ahead and calculate this. 31.42 divided by 32.065. We'll get this. Answer needs to be rounded down to 4 significant digits, so that'll be 0.9799. So 0.9799 moles of sulfur. Alright, great. Okay, let's go ahead and do the next problem here. Next element here, sorry. So, oxygen. So, how many moles of oxygen is 31.135 grams of oxygen? 1 mole of oxygen, if you look at the periodic table, you'll see that 1 mole of oxygen will have 15.999 grams of oxygen. Okay, I'm just trying to save time, so I don't want to flip back and forth between the periodic table and this. Grams of oxygen cancel out with grams of oxygen. We're left with moles of oxygen. So then from here, 31.35 divided by 15.999. It's going to give us this. Our answer needs to be rounded down to 4 significant digits, right? So our answer, we're going to notate it as 1.959. .959 moles of oxygen. Okay, and for our final element here, fluorine, we have, let's see, 37.23 grams, so we're looking for moles of fluorine, and we're given, let me look at this again, 37.23 grams. Okay. And then from here, we know, if you look at the periodic table, that 1 mole of fluorine has a mass of, let me see here, I'm not sure, I didn't memorize this. Looks like 18.998. Let me make sure on that. Yeah, 18.998. Great, so you can put that here. And then grams of fluorine cancels out with grams of fluorine, and we get what we want. Here we can get our calculator out. 37.23 times 1 is 37.23 divided by 18.998. And that's going to give us 1.960 moles of fluorine. Alright, great. Now we can go ahead and divide by the lowest number of moles. We have 0.9799. We have 1.959, and we have 1.960. So we're going to have to divide by the smallest number here, which is 0.9799. So divide this point by, let me use a different color. Divide this by 0.9799, and you will get 1. Divide this by also by 0.9799, and you will get, let me see, .959 divided by 0.9799, and you're getting 1.999, which can be rounded down to 2, up to 2, getting 2. And here we have 1.960 divided by 0.9799, and we are getting 960 divided by, I'm getting 2 again. Okay, it's very close to 2. It's not exactly 2, but it's very close to 2, so you can just take it as 2. So this equals 2. So from there we can determine our empirical formula. So it's going to be S1O2F2. So just SO2F2. That's the empirical formula. Okay, and now let's go ahead and determine the molecular formula. So we have the molar mass of the molecular formula here, 102.2 grams per mole, and we're gonna have to find the molar mass of this here, the strange compound. So let's go ahead and do that. So we know 1 mole of this. 1 mole of SO2F2 is going to consist of 1 mole of sulfur, 2 moles of oxygen, and 2 moles of fluorine. So 1 mole of sulfur, if you look at the periodic table, it's going to have a mass of 32.065 grams. So 32.065 grams. 1 mole of oxygen has a mass of 15.99 grams, 999 grams from the periodic table, so 2 moles of that is going to have a mass of 31.931, not 21. 31.998 grams, and then 1 mole of sulfur, we just had this information here, has a mass of 18.998 grams. So 2 moles of that, we can multiply this 18.998 times 2, and we're getting 37.996 grams. Now we can add this all together, all these together, excuse me. So 32.065 plus 31.998 plus 37.996. I'm getting 102.059. So the molar mass of our empirical formula is 102.059 grams per mole. Now, if you look back, the molar mass of our molecular formula is also 102. Very close to this, 102.2, 102.059. This is a very small difference. So therefore, our empirical formula is exactly the same as our molecular formula, because think about it, if you divided 102.2, the molecular formula, molecular molar mass, by the empirical molar mass, 102.059, you'd get a number very close to 1, and when you multiply the subscripts by 1, you're going to get the same thing, right? So because of that, the empirical formula is the same as the molecular formula. And sometimes that will happen, so if that does happen, it doesn't mean you did anything wrong, it's just a special case. Okay, this video is starting to get long. In the next video, I'm going to break it down into 2 parts. In the next video, I'm going to go ahead and explore the last 2 problems here, which are a little bit more challenging, but for now, empirical formula and molecular formula are as simple as that.